had three variables in setting this up. One, I was told, when was it, Maria? 1 or 2 days ago, that I had to speak somewhere between 20 and 40 minutes. So we'll see what happens. This time the second variable is I had no idea what Matthew was going to tell you, so I had to plan around that. And the third is I wasn't sure who was going to be here. I'll switch back and forth. There we go. So who heard the NGFF talk in global bio? Who did not hear? Excuse me. Who's new? You know. Okay, so I'm not going to give the introduction to NGFF, right? So I'm going to save you that time, so that we can get to other things. Let's see. All right, know that. Okay, so right, short version is we're creating web resources that are linkable, and we'll look at a lot of that. The bit that I left out, since I didn't have enough time last time, the clock's not moving, that's fine for me, is that the way OMESR began is there were a couple of communities who had made very, very similar advancements. They had made a choice. So one was storing their multi-resolution pyramid with a S prefix in the directory structure, one without a S prefix in the directory structure. Some were storing their pyramids from little to big, some from big to little. And what we needed as a community was just to sit down and agree on something. And so that's at the binary level, but it's very similar to the conversation that we're having in GUIDE, right? So all of these things, they're not huge decisions, but it's about agreeing on something, getting started, moving forward, iterating, right? And you've heard that bunches of times already. And so you can read the history of doing that with OMESR. There's no magic behind it. It's really just getting the community together and working on these things. We did this, papers, there'll be more papers. If you're interested in being on the papers, talk to me. So all these drawings come from the ZAR community. So we hired an artist funded by CZI, so thanks, shout out, it's the EOSS program, but in general, just supporting our ways of communicating with the community. This is what we're doing. Here's how you understand it. This was trying to get across when you've got these data structures and they're open and transparent and you know how to access them, the hope is that we can start just passing them around and we actually start to get to the reuse that we talked about so much last night. This is obviously coming from the bottom up. It's the infrastructure. You all have to make the scientific case, as Jason pointed out, but we'll meet in the middle, right? So this is why we did the challenge. I said this, I'll repeat it very briefly. OME2024, we've said it multiple times. We set ourselves up these 4 months and said, how far can we go? So this is challenge number 1. There will be more. I think, yeah, I had left out these slides, so the specifics. It was all about this RFC2. You can go and you can read it. Norman Sepka is from Scalable Minds. They work in connectomics. The connectomics community for many years has had these problems, so they developed their own file format. Google, with their NeuroGlancer tool, also connectomics, developed their own tool because they had to. They had this huge data. They needed to pass them around on the web, so they built a format. And with OMESR, they're finally coming together. So both Norman and the lead developer of NeuroGlancer, Jeremy Mighton-Shepard, are involved in the community. They're helping to build these specifications. And so this was trying to get us to the next major version of ZAR, but we hadn't tested it yet. And so the challenge was all about testing it. The changes, once again, so much of this stuff, it's not rocket science, right? I mean, it's not even biology. What's the take home here? We cleaned things up. It got easier to do what we wanted to do. So from the technical level, there were just the advancements we needed to make. The other big one is that, I mentioned this very briefly, is this concept of sharding. It makes this usable for many of your IT systems, right? ZAR has lots of little chunks. It splits them up into lots of files. With sharding, a shard is a group of chunks. You have fewer files, but we still get all the power of ZAR. So it's constantly about finding the technological advancements that balance what we all need, right? And we just needed to test that. We needed to just jump in the water and do it. The other is what Matthew told you about, so I won't go into this too much. We'll actually look at it more concretely in a second. Ultimately, So a lot of the work can get summarized in hocus pocus, this just works, right? And so any of you who participated in the challenge, that's a group from RIK, that's a group from EBI, from IDR. I guess you've seen the names in the UI. Ran this command, right? And this command was doing things in the background in a high-performant way, creating these systems and generating terabytes of data. And so we all did this, and we didn't run into the problems that we could have had. I've told some of you, people have asked me, how are you doing? Is everything all right? It's like, things are fine. This worked, and so I'm happy, right? And we moved forward. Showed you this last time, and we'll look at, we'll swap over to the browser in just a second and look at this. If I had been given the 40 minutes, if Graham's still around, I was going to see if Graham wanted to pop up and show us his version. If not, but if you have time, try to get Graham and he can demo that. I do have it open in a browser, so maybe I can do it, but I don't want to do anything wrong. Lots of these tools that are these web resources that lets us bring all of this together. And critically, in less so in the challenge, but more so in these other tools, lets us do more interesting stuff with the metadata. So we'll look at that. Already had this slide, but it was exciting, right? And we've been talking about this a bunch. It's kind of become a theme, certainly over the global bioimage session, and it's been mentioned a couple times over the past 2 days. This is the general timeline. So it went, that green's quite aggressive on this screen. And you'll notice since my slides are all being done on the fly, the Zenodo link, unusually for me, does not resolve. I'll get that fixed up and you can have the slides later. Okay, let's get to foundingGIDE, right? So this is the trajectory of how we try to bring bioimaging, so the research data and the image data together. I think, or I feel very similarly when it comes to NGFF and all the metadata we're talking about. So we have to get the format and we have to have a place where we can store the metadata. We also have to define the metadata and have a place where we can put in the format. Right? So there's a lot of this convergent development that we're going to be doing. And so, right. So this is now going to start getting much more into almost hackathon vibes. So I have Lucy in mind when it comes to this. So she said, from the biologist's perspective, she kind of wants to understand what's going on. So Lucy, tell me afterwards how well I did. And also talking to Vlad, there was a question of how do you scale up? So we did this. There's multiple S3 buckets with all of this data, the terabytes of data. How do you do search, for example, which was one of the goals of foundingGIDE? How do you do A? How do you do B? And we're going to need to figure out. I don't have solutions. This is all just kind of preliminary work. But what I could do fairly easily, because these are all, the whole purpose of ZAR is to open things up, have everything separated and web accessible, took all the metadata from all of the buckets. I think it took a little over an hour. And it's not the latest version, but getting ready for the hackathon, I extracted all the metadata. It's on GitHub. So you can go and you can actually see all the files that, for example, Matthew was talking about this morning. I think it's currently 15,000 row crate files. You can play with them, you can pull them into a database. We need to experiment to figure out what's going to work for the community. But the fact is, that is now archived, right? And that metadata can be archived, can be put on Zenodo. You can give it a DOI. All of that is technology that exists. We don't have to build it. Make the hard things easy, right? Okay, so here's where things get fun. Matthew showed this. So you now know how long I've seen this slide. And this is what I'm going to now try to work towards. Right. Choose your own adventure. Okay, let's do it. So, foundingGIDE. So going a little bit back in time before we get started, this is a much older web page. So when we began with OME-ZAR, we built a static GitHub page, as many of us probably have. All of the data is just stored in a CSV in a single repository. So this isn't federated. But this is what we used to develop OME-ZAR. We took, every time we came up with a new specification, we took the data from the IDR, we converted it, we did all of our testing, and we put it online and just cranked that wheel, right? And you can come here and you can play with it. Sorry, I didn't give you the URL. I hope that's visible. Try some examples. I won't click on anything else. Let's see, I need to go lower. To explain the icons very briefly, well, I guess I should explain the columns too. So you can see each of the different versions of OME ZAR that we've had over the years, starting from the oldest. Then you get a thumbnail. Then you have these icons. Something that's weird about S3, and so this was, again, a conversation we had last night. Fundamentally, object storage and S3 and the cloud works differently. It confuses people, and that's just something we're going to have to train people on. These links, you click on them, I guess I'll do that. I didn't prepare that. Kind of get garbage. Not very user-friendly. There's just not a ton I can do about that. The reason is, I mean, this looks like a file, but it's actually just a prefix. It's the beginning of where you want to go to look for your data, right? And so that just doesn't do much for you. You need that URL, and you could pass that URL into Mobi that we saw from Lucy. You could pass it into Napari. You can put it all over the place. It's valuable. It's just not something you can look at, right? So it's a bit different. It's something we're going to have to teach the community. So we put all these buttons here. You click this button and then you copy that. It's now on my clipboard, and I can paste it up here if I want it, but we don't want to do that. The check mark is the validator, and I'll show you several of the validators like this in just a second. And then you start to get the GUIs, right? You have VZAR as one GUI, BTK is from the ITK community. That might be all we have in this page. It's a little bit older. And then you have the metadata that we thought was interesting, like a link to IDR if you want to see the original data. All things you can play around with, and we'll see a little bit more of it. This is a 2D image. It's not horribly exciting. I love it because it was one of the biggest challenges I've ever experienced in my life. In 2012, this was the biggest image on the internet. It's only 500 gigabytes. It's basically nothing now. But it was gargantuan. And we put it on a server in New York, and 3,000 people clicked on it a second for days and days and days. It was horrible. I actually went on vacation and left the rest of the team to work on it. It was mind-boggling how much we had to do to make this work, right? Things were falling over, people were staying up all night, and now it just kind of works. And there's no server behind this, at least not one I have to run, and that's great, you can imagine. Now there are much bigger images that we have to deal with. So the biggest one we have in the IDR currently is 407801. Jason showed it in many of his slides much more attractively than I do. This is the McDowell embryo. Okay, the reason I bring it up is because the data, if you decompress it, is 9 terabytes. And that's this volume. So it's not too bad in X and Y. There are 1,000 slices, but it's a movie. It has 500 time points, 500 of those volumes that you can look through. That looks like this in the browser, in a 2D browser. It's not made for 2D, but I'm showing this example. This is as geeky, okay, this is the second geekiest thing I'll show today. So this is the viewer, and this is what's called the inspect window in your browser. It tells you everything that's going on. And the reason I bring it up is if I start to zoom in here, you'll see, hopefully, I'll just reload the whole thing. Here in this panel, you're seeing every call for a chunk of the ZAR as it happens. That's each of these little files. And down at the bottom, you see how many megabytes are being loaded. Now, this is fairly slow. It's over, conference Wi-Fi, and you can barely see what's going on. But that's how ZAR works. And so you have all these URLs, and everything's being loaded on the fly, right? That's what it's all about. It's having each of these chunks of your data. Every pixel is in a chunk, and you know precisely where they are, and you can load them. And that's really the only secret. Nothing else is happening. And all these chunks are down below that S3 prefix that I showed you. I'm gonna have to speed up. Anyway, here's the challenge. And now we're back to the challenge website. We've jumped forward several years. You have all the participants who've sent their data. I think here, right. So here I've clicked on mouse. You see the McDowell data again. There was one thing I wanted to show you. So this is really what's driving the whole challenge. It's a single CSV. You have each of the participants, and you have their data loaded somewhere. Eventually, we pulled in all the CSVs into the GitHub just to make it easier. GitHub's there to work on things as you're very active. But originally, everyone had their own CSV. So all we needed to know from the participants was one file. That was their full submission. And then what comes out of that is now the McDole data. And rather than having, where's the number of chunks? Here, 6 million chunks. In the previous version, the grand success, I guess, of the challenge is that we're now down to 190 shards. That's the difference, right? That's why we had to do RFC2. That's why we needed the new version of ZAR, is because IT was telling us to go away if we didn't reduce the number of files. So we did. Check. So I really could have just left the whole presentation at that. Okay, zooming along. In the new version, you can kind of look in the validator and you can see the architecture of your volumes. You can see, so the blue lines are the shards. The black lines, which are much harder to see, are your individual chunks. So you can get a feel for how your data is laid out. And hopefully most users won't have to worry about it, but the people who are generating the data do need to care, because it influences access patterns, right? Depending on how you want to work with your data, you likely will want to change some of these parameters. And ZAR is all about giving you the knobs so that you can tune and you can adjust, and all doing it in a standardized way. All right, let's get into metadata to make the bridge. So we're back in the challenge script. Oh, there's no row crate there. Where did the row crate go? Okay, I'll show you one more data set. And it is coming, we're using here Neuroglancer. So a 3D data set, also using shards. And I think what I wanted to get across here is we needed to create versions of this software. Neuroglancer is a tool built by Google. It's a static website, so you just have a URL. We could host our own anywhere. So here's a URL. So this is my repository where I put all my challenge data. It's just sitting in S3 beside the correct data. So here's data, and here's the application that can view it, sitting side by side. You can actually, so let me say that again. You can put the viewer for the data inside the data if you want. That make sense? It's bizarre and it's great, right? Ah, it's bizarre. Wonderful. Someone got the pun. Thank you. All right, there's all the metadata. Okay, now here's what I tried to do based on Matthew's presentation. So he said, blah, 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 can I find mitochondria? I didn't have enough time to parse all the 20,000 JSON. So the search turns up nothing. But if I change this to, what was it, HeLa, I can find some descriptions of HeLa cell, right? Not amazing, but it's a start. Important things to take home. One, there's a query language. There's a specification, a standard for querying across metadata. You might not need to care, and hopefully most of you will never need to write these queries, but for those of us who are writing software, it's a big help, not to have to do everything from scratch every time we want to build a web page. I know I had something with metadata in it. Let's try a new one. Okay, so in the validator, when you click on one of these terms, so Matthew showed you these, currently you just go to the definition of what that term is, because you're validating something. You want to know, do we agree on what the definition is? But much more importantly, long term, you will want to be able to search based on these. So imagine a different web page. So that's what the validator's for. But if you're building your own portals, when you click on that, you should find all of the images that are HeLa cells, right? It becomes the way to link our data together and find knowledge. I think I'm now, as always, horribly out of time. That's the program that Graham can show you. It's the Allen Cell Science Biofile Finder. There was a poster on it. And I think the last thing was just, oh, I was going to show the correct data to get back to Lucy. So there you go. I'll leave you there.
Thank you so much, Josh.
I'll put up one slide while there are questions. Since Matthew said I would do all the acknowledgements, I'll put those up again to be polite. It was great to have that many people participating in something without being paid for it. So anyway.